Hello guys, today we are going to discuss about the system design of flight booking system. So first of all, we need to gather the requirements. What are the functional requirements and what are the non-functional requirements? Functional requirements are users should be able to search flights according to the date, source, airport ID, destination airport ID, and then user should be able to book the flight. Once booking for the seat is initiated, then the booking for the same seat should not be allowed. Once booked, the notification should be sent. The user should be able to see his past bookings and upcoming bookings. The system should be able to integrate with any new airlines. Okay, so these are the functional requirements. Now let's come to the non-functional requirements. So the system should be highly available. So for good user experience, because we have a famous CAP theorem which states that only two out of these three, consistency, availability, and partition tolerance, can be achieved at a time. So in flight booking system, we will prioritize availability and consistency, fairly consistent. Okay, and latency should be low. Okay, so these are the functional and non-functional requirements. Let's draw some diagrams. So first of all, let's dis discuss about the airlines onboarding flow. Okay, so so suppose there is an airline called Kingfisher, and Kingfisher wants to register to a particular airport, the particular flight, that this flight is available between so and so time at this airport, and source city is this, destination is this. Okay, so we will have the search service first of all. So whenever search service come, it will use Elasticsearch. In any system design, if you talk about search service, you should also talk about Elasticsearch. Okay, so Elasticsearch consumer, when searching from the web UI, they will also use the Elasticsearch. Okay, now we have the airline service, which will call a API to register the flight schedule. Okay, so it will basically call to the Kafka, which is a data streaming pipeline. So airline will call register flight schedule. Okay, let's call this API register flight schedule. And in the parameters, it will pass these uh, things. So we have this flight schedule. Okay, so parameters can be flight schedule ID. Okay, what are the seats, list of seats? Then number of seats available. Then we have what is the start date time and end date time. What is the source airport ID and destination airport ID? Okay, so one city can have multiple airports, so that's why a city can have a multiple airport IDs. So we are talking about a source airport ID and destination airport ID. And then we have the cost of the ticket. So these are the flight schedule. So this is the airline's onboarding flow. Now let's discuss about users search and booking flow. Okay. So user will can either use the web UI or app. So we have web UI app as a front end. It will basically go to the load balancer. Load balancer will decide where to navigate. Okay. Load balancer will decide whether it wants to navigate to search service or booking service. So let's have two services over here. So this is booking service. What happened? Yeah. Then we have search service. Search service will always use the Elasticsearch. So let's have the Elasticsearch here. Okay. Search service will use Elasticsearch. Load balancer will navigate the request. Booking service will call the third party API to block the seats. So third party API will be of airline service. Okay. So booking service will call this one. Then after blocking the seats, it will call the airline service. To actually block the seats. Now this Elasticsearch will basically use Kafka, okay, to get the data. And the what should be the API look like? So for booking, the API look like this. Booking slash we can have user ID who is making the booking, or I think user ID is not required. So for booking, we will have the airlines ID and we will have the Seats, seat IDs. Okay, these two are main thing. User ID, because we want to maintain the records, so user ID can be also there. Now for search service, what should be the API look like? Search date, okay, and source airport ID, source airport ID, and destination. Okay, this can be the search service. Now we will have Kafka. Whenever Elasticsearch come, we will have the Kafka. Okay, Kafka is basically for data streaming. So let's talk about user trips and user profile flow. So user trips and user profile flow. So user will use either web UI or app. Okay. So here we have the request first will go to the load balancer. Load balancer will route the request whether user want to see his um, booking history or user want to see his profile. Okay, so we will have two services. First one is booking service. Okay, so let's have booking service. Now booking service can call the database. So we will have the master slave database for scalability. So in master database we will write, and in slave databases we will read from there. So let's have some databases. Yeah. So this is kind of a SQL database from a booking service can query. So let's have, okay, this is a SQL databases. Now to increase the performance, we can also have NoSQL databases. We can use Cassandra cluster. So let's use Cassandra cluster here. Okay, so it's a NoSQL database. It is used to increase the performance of the system, and indexing can be on booking ID. So we have indexes over here, indexes, booking, and user profile. Okay. So yeah, I mean, this looks good. So that here we will have, instead of booking service, we will have user service actually, because we want to get the information of the user. So API would be like user slash booking. Okay. The another API can be like user slash user info. So these two can be the APIs. User ID. Okay, these two APIs are used to get the information of the bookings of the user and user information of that user. Okay, now let's talk about the notification flow. So whenever the payment is successful, okay, uh, whatever, if it is failed also we need to send the notification. So we have this payment service. It will send the status of the payment to the booking service. Okay. Now booking service will call the user service to get the user contact details and preferred mode of notification. After getting the user contact service and preferred mode of notification, booking service will call the notification service here. Notification service. And notification service will send the notification to the Kafka. So the event can be in the Kafka queue. So we have the Kafka over here. Okay. Now Kafka will send the, so notification can be sent via WhatsApp, via SMS, via email. So we will have three consumers: WhatsApp consumer, SMS consumer, email consumer. And then we will have email consumer also. Okay, Kafka will redirect the notification to these consumers. So notification event, what should it look like? It can be like this. So notification event, right? Uh, First of all, user ID will be there. Second, booking ID will be there. Status, content can be also there. Okay. And user booking ID and flight information. So these all the data can be present in the notification event. So this is our notification flow. It looks good. Let's talk about payment and transaction flow diagram. Payment and transaction flow. So booking service will send the will call the payment service. Okay. We'll call the payment service. And booking service will also call the third party API to block the seats. Okay. Now payment service will call the payment gateway. For the payment status of the payment. And payment gateway will do a callback and return what is the status of the payment. Now payment service in the meantime will create a transaction ID in the Redis. So we have Redis over here. Okay. And payment service will also create booking ID with transaction ID in the MySQL cluster. So let's create a MySQL cluster with the master slave setup. Okay, so this is our MySQL cluster. So payment service will also update here with the booking ID and transaction ID. Now what will happen? There can be three scenarios. First one is payment is successful and TTL is not expired. Okay. In that case, the entry in the Redis will be deleted with that transaction ID, and the status of that transaction in the bookings table will be successful. Earlier it was processing, now it will be successful. Second case is TTL has expired. Okay. TTL has If the TTL is expired, then either payment can be successful or not successful. But if TTL is expired, then we will update the status in MySQL cluster as failure. And if payment from payment gateway we get the payment as successful, we will revert the transaction and credit the money into the user's account. And we will also delete the entry from the Redis with that transaction ID. And if the TTL is not expired but status is failure, in that case, we will delete the entry from the Redis, and we will update the status in MySQL database as failure. Okay. And then we have payment service. Yeah, so if payment is successful, then payment service will call the third party API. uh, to mark the seats as taken. If the payment is failure, then payment service will call the third party API to uh, unblock the seats. And then we can have a Cassandra cluster also for increased performance. Okay. Indexes can be on booking ID. Okay. User ID. These two can be done indexes. So this is Cassandra cluster. Yeah. And we can have a archival service as well. So this service is basically used to archive the bookings of the users. Okay. So user can have a booking history of 200 bookings, 300 bookings, or whatever it can be. So archival service is used to archive the bookings and store it in the Cassandra database for faster processing and faster accessing the data. Okay. Yeah, so archival service, this service is used to archive the bookings. Okay. Yeah, so that's it. That looks good. This is our payment and transaction flow. From booking service, we will call the third party API to block the seats. We will call the payment service to initiate the payment. Payment service will call the payment gateway to get the status of the payment. Okay. And in the meantime, payment service will create an entry in the Redis with the transaction ID. So if payment is successful, then payment service will delete the transaction ID, and in the MySQL cluster, it will have the record with transaction ID, booking ID, and status as successful. And it will also unblock the seats here. Okay. So payment service is the center of the system in this payment and transaction flow. So I hope this video is useful. Please do like and subscribe. Thank you.